this video, I'm going to look at some features of graphs. So this video is entirely intended for students taking an end of course exam, one of those big state assessments at the end of a school year. And they just need a quick refresher on the different features of graphs. So we've probably talked about these already throughout the school year, but this is just a very, very fast refresher on these things. So one thing you might be asked about is intercepts. Intercepts. We're going to talk about what they look like visually and then what they look like a little bit more written out. So visually, what an intercept is, specifically an x-intercept, is anytime your graph crosses the x-axis. Where your graph crosses the x-axis, that is an x-intercept, okay? A y-intercept is just anywhere your graph crosses the y-axis, anywhere your graph crosses the y-axis. So x-intercepts, where the graph crosses the x-axis, y-intercepts, where your graph crosses the y-axis. The thing I want to point out is when you're identifying and labeling x and y-intercepts, we're going to write them as points. So like this x-intercept here, we're going to write the xy coordinate of where that x-intercept is happening. So this xy intercept is happening at -1 for the x value, but 0 for the y. For the y-intercept, we're just writing out the coordinates for where this y-intercept happens. The x value here is 0, but the y value is -2. The one thing I wanted to point out that's a little bit interesting about x and y-intercepts is when you're talking about x-intercepts, the y value is going to be 0. When you have x-intercepts, the y value is going to be 0. When you have y-intercepts, the x value is going to be 0. You see how those are kind of opposites there. For an x-intercepts, y is 0. For y-intercepts, x is 0. A little bit of an interesting characteristic there. Next thing I want to talk about is increasing and decreasing. Increasing and decreasing. So I have just a basic polynomial drawn here. When we look at our graphs, I kind of trace it with my fingers starting on the left side of the graph and move to the right. So if I trace my graph starting on the left side and moving to the right, and I'm tracing this graph, we start down here, we go up, and then we come down, and then we go up. When we're asking about increasing and decreasing when it comes to functions, increasing is just where is your graph going up, and decreasing is where is your graph coming down. So on this graph, notice I use the words I'm going up, up, up. This is increasing, increasing, increasing. Then we hit this point, and we turn around and we start coming down. So here's where we're increasing, and then here's where we're decreasing, and then one last time we turn and we head back up and we're increasing. So my increasing happens from all the way down here at -infinity all the way up to this point. Our decrease goes from this point to this point, and then our increase turns around and goes back up right there. So we have increasing, decreasing, increasing there. That's what they're talking about with increasing and decreasing. The final thing I want to talk to you about is, well, not the final thing, I have two things, sorry, is asymptotes. Asymptotes. So I have a rational function over here, and I went with an exponential decay function over here. Asymptotes is something that when we have our graphs, your graph is going to approach and gravitate towards those asymptotes. Now, on some graphs, our graph will never cross these asymptotes, but there are graphs out there that exist that our graph will cross the asymptotes. But an asymptote is something that our graph is always going to be approaching and try and get nice and snug and up next to it. So for this rational function, we have a horizontal asymptote and a vertical asymptote. So you notice my graph, it's snug on this vertical line here, and then it jumps across to get snug on this horizontal asymptote over there, okay? So we could find the equations for this vertical line. It's going to be x equals something, whatever number, and in this case it's x equals -3. We could find the equation of this horizontal asymptote, and with horizontal we always use y. That would be y equals 5. So asymptotes is something that our graph is going to get nice and snug next to. Sometimes it crosses it, sometimes it doesn't. In my exponential decay function, remember, we start really, really high. We come all the way down and we get flattened out here. This is a horizontal asymptote that my graph flattens out, gets really, really nice and snug to. That is what an asymptote is there. The last thing I wanted to put on here, I didn't label it super well, is end behavior. End behavior. This is just describing as your graph ends on your paper, like what's the behavior? Where is it going? So this graph over up here, it's increasing on forever and ever and ever. That's the end behavior there. This is going to keep on going out sideways that direction. End behavior there. A better one to talk about is this polynomial graph. The end behavior is in the bottom left, we're still going down, 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 down to negative infinity. On the right, there's an arrow going up. That's because this graph is continuing up in the positive direction all the way up to positive infinity, okay? So these are just some basic features of graphs that you might be asked about on the end of course exam. The intention of this video was just to give you a quick refresher so you understand what they are.